Okay. 1.5c. We're going to discuss some functions and their inverse. You ready? That's the review worksheet. So we have a quiz next time I see you. We have 2 parts today. It's pretty quick because we do want a review for that quiz. So letter A, we're going to talk about functions and specifically one-to-one functions, what that means. Okay, one-to-one functions means that the graph of your function, the graph will pass, first to be a function, okay, the graph's going to pass the VLT, the vertical line test, but to be one-to-one, you are also, and you're going to pass the HLT. Okay, one-to-one means for every element in X, you're getting one in Y and vice versa. So you know how a parabola, basic parabola, is a function, right? Every element in X, when you plug in 3, you get 9, right? When you plug in 1, you get 1. You plug in -3, you get 9. Now to be a function is you plug in a number and only one number comes out. Now that number can repeat. It's okay for both of those to be 9. So in order to be a function, the x's can't repeat. Okay? So this vertical line test passes. This point -3, 9 and +3, 9, that's okay. No big deal. But this is not one-to-one. Because see how 9 matches with 3 and 9 also goes to -3? You can't have that. It's kind of like if you have girlfriends over here and boyfriends over here, one girl to one boy, you can't have a girlfriend that has 2 boyfriends. That's not a fun. You can't have a boyfriend that has 2 girlfriends.
One girlfriend, one boyfriend.
Yes, that's one-to-one. Okay, so knowing that, number 1, the question is going to be, and these are yes or no. You don't have to show work. It's going to say, is the relation one-to-one? And they do 1-1-1 like that. That means one-to-one. Okay? Is the relation one-to-one? These are just yes or no questions. So let's do some. Letter A. Y equals x cubed plus 1. Now, the easiest way to decide if a relation is one-to-one is to graph it, okay? So you take your calculator out or you use your brain because most of you know that this is a basic cubic function just shifted up 1. You probably should know that. Do you know that? No? Yeah, we did that in Ram and Ham. We did parent functions and all the shifting. So this is what it should look like. I didn't even graph it on my calculator. You should know what that looks like as the graph. It's just x cubed shifted up 1. Is that relation a one-to-one relation? Yes, it is. Yes, it is for sure. It passes both the vertical line test and the horizontal line test. Okay, pretty easy, right? Let's do another one. Every day. How about y equals x cubed minus 4x? Now, you also know how to graph that without using a calculator. You do. Well, you could, but what happens if you don't have it?
Wait, you're going to take
sometimes there's no calculator section. Well, let me show you how to graph this really quickly. Let's find the zeros. Okay? If you were to factor out a GCF, that would be x. And then if you were to keep factoring, you would get x plus 2, x minus 2. Now, do you remember doing this in your class last year? Your zeros are 0, do you? -2, and +2. And this is a regular x cubed. It's a cubic function, so Polynomials, they're nice and easy. There's no weird stuff going on. They just go like this and this and this. Okay, so I saw some people shaking their head already. They knew what that was going to look like. This was a cubic function. It was 1-to-1. But this cubic function is not. It is a function, yeah, but it does not pass the horizontal line test. So this is not 1-to-1. So the answer would be no. What about a circle? Is a circle 1-to-1? No, not at all. Okay, how about this one? Y squared equals x, but only when y is greater than or equal to 0. That's a weird one. Do you know what y squared equals x is? Do you know what the graph of that is? Yeah, sideways parabola. Okay, it's this and this, except that it's just the top. It's just when y is greater than or equal to 0. So I can get rid of that part, okay? It's only the top. Now, if I'm just looking at this one right here, I'll draw it in red. That's all it is that 1-to-1. Yes, it is. Okay, so be careful. They might be a little tricky. They might restrict the domain or range, and then you look at them that way. All right, so that's 1-to-1. It's a nice conversation. I remember when I was in college, we were talking about 1-to-1. I never got it. And it's just like one of those things. You have like a couple of those math terms that you're just like, you just never get it. Every year they talk about it, and you're just like, nope. Calculus. We haven't even gotten to calculus yet. All right, how about inverses? Everything we've done so far is Algebra 2 or pre-calc? Oh, the class in general. Got it. Okay. All right, now 1-to-1 functions are going to have inverses that are also functions, okay? So what we're going to do is we're going to find the inverse of a function. So to find the inverse, do you remember what you do? You do two things, basically. Perfect. You switch the x and y, and then you solve for y. Okay? Sometimes you have to fix it. Sometimes you have to restrict the domain, stuff like that, but we're not going to do too tricky of problems. So here we go, number 2. There is a tricky one coming up. Find the inverse. And do you remember the notation for inverse? F to the negative 1 of x, f inverse of x. That's the inverse notation. What happened? Nothing. Did you go to In-N-Out today?
Me?
Yeah.
No, I keep the cups for when I want to let you down In-N-Out.
Okay. I don't believe you. All right, here we go. Let's do that one up there. F of x equals...
So you did go to In-N-Out.
Yeah, she would.
Okay.
F of x equals x cubed. Are you in service, leadership, 4th period? No? You are. Oh, yeah, but you know what? I saw a girl wearing like a tennis shirt and she's not in tennis, so. Okay, find f inverse of x. So first thing you're going to do is you're going to switch x and y. Now if you're like, oh, there is no y. Well, f of x is y, so let's go ahead, we'll switch it. X equals y cubed. And now we need to solve for y. To solve for y, we're going to take the cube root, right? Both sides. So y equals the cube root of x. And that's it.
Wait,
Very simple. Find the inverse.
Right. Okay. I forgot my gloves at home today.
Oh.
Yeah.
Here is the graph of f of x. Okay? And I don't know if you know what a cubic function looks like. It's a little strange. It looks like this. Like it kind of goes like that. Okay? And you should notice that inverses are always reflected over the diagonal y equals x. You didn't know that? Yeah. Y equals x. They're a reflection.
What?
Yeah, inverses. So the blue one is the cubic function. That's the f of x that we started with. And the green one is the cube root function. And if you were to fold them along that imaginary red line, it'd be a reflection. That's actually a really good drawing. You guys lucked out today because I've really messed that up in the past. All right, letter B. Let's do this one. F of x equals 10 to the x. Because you're probably wondering, why are we doing these functions when we've been doing logs all week? Well, this is why. So f of x equals 10 to the x. We're going to find this guy's inverse. So take x and y and switch them. So x equals 10 to the y. And now we have to solve for y. How are you going to solve for an exponent? What do? Yeah, you log both sides. So we get the log of x equals the log of 10 to the y. Bring that y down. So I get log of x equals y times the log of 10. What is the log of 10? It's 1. And so the inverse would be y equals log of x. So these two things are inverses of one another. Yeah. Should we graph them on our calculator to see? Yes. Yes, we should. It's easy, it's quick. 10 to the x and log of x. Now, if I were to just go a regular viewing window, they look pretty good. Sometimes they don't, because our window isn't a square window on our calculator. So if you did zoom square, it would actually look a little bit better. But one's an exponential graph and the other one's a log graph, and they are a reflection. I'll draw it over here. So here's your 10 to the x, an exponential graph with an asymptote through here. And then our log graph goes like that with an asymptote going that way.
That's crazy.
It is. It all makes sense though, doesn't it? No. No. Okay. All right, number 3. How many more, you ask? 1, 2, 3, 4, 5. I don't know, 5. Okay, here we go.
Wait, how many?
I like 3.
That's a lot.
F of x equals 2x plus 8. All right, there's a line, right? Simple line, slope 2, y-intercept is 8. Let's go ahead and find the inverse. You try this one, okay? You try it all by yourself. Try number 3. So I would start by switching x and y, and then I would solve for y. So subtract 8 to the other side, and then divide everything by 2. Now you're probably very tempted to just write this over 2. Okay, that's kind of gross. If I told you to graph that, would you think that was a line, or would you be like, what is that? You graph on your calculator, yes. Well, this is just simply x over 2, which is 1/2 x minus 4. That's much better. That looks better. It actually looks like a line. So a line and a line, those are going to be inverses of one another. Now, there's something else that we do, number 4, is that you're going to have to verify that something is an inverse. Yes. Verify. So the way that you verify is you do f of f inverse of x. Okay, that's one way. And the other way is f inverse of f of x. Now, you're supposed to do both, but you know what? I don't make you do both. I just make you do one, okay? We're good one. Some graphs, though, you will have it that it won't work out both ways, but we hardly ever thought. Anyways, what are these going to equal? Do you remember? No? Close. Close. Something very simple that's just going to equal x. It does. Okay? It's kind of like when you plug x in to something that undoes that something, you just get x right back out. Doesn't that make sense? Like if I cube a number and then I cube root it, because those are inverses of one another, I still get that same number back. Okay, so you just get x right back. So let's go ahead and verify that last one, the one up here. So let's say that f of x is equal to, what was it, 2x plus 8? And then we found that the inverse was 1/2 x minus 4. Is that what we found? Yeah? Okay. Let's go ahead and verify. We'll just verify one way. We'll verify by doing f of f inverse of x. And let's see if it actually works. Who's this for? Carly and Faith. Ooh, you've been picked for a pep rally game. We have an assembly on Friday. Oh, but you're supposed to come at lunch on Thursday to find out what the game is. All right, I'll do this one with you. Let's go ahead and pick up the inverse. We're going to pick this one up, and we're going to plug it into our function. We did this already this year, right? We did composition of functions, or not? Yeah, we did. Yeah. All right, so you get 2 times 1/2 x minus 4 plus 8. Can you kind of do that in your head and see what's happening? Yeah, I hope so. 2 times 1/2, you get x minus 8 plus 8. And we got exactly what we knew we were going to get. Okay? What that says is if I take a number and plug it into x, it's going to come out as something. I plug it back into the inverse, and I'm just going to get that same number right back. It's like undoing and doing. Okay, last one. You okay? Number 5. Oh, wait. I kind of have 2 more.
Just do
Sure.
5 more just for fun.
No, I kind of had 2 more, but yeah, I don't have to do them all, but then you'll get to the homework. Why didn't she teach it?
Just do
All right. F of x equals, so this is going to be the hardest one. You can do it. X plus 1 over x plus 3. Okay. And we need to find the inverse. Find f inverse of x. Okay. Now, this one's tricky. I believe that we did this in ham, but not RAM. So pay attention. Here we go. First semester, yeah. We're going to switch x and y. Okay? So x goes on this side. What happens is y goes over here twice. Okay? You got to plug it in for both x's. So x and y switch. And now we have to solve for y. And this is tough. Solving for y when y is separated like that, it's not easy. So let's do this. We're going to now cross multiply. So you get xy plus 3x equals y plus 1. Okay? And then what you want to do is you want to get your y's on one side and everything else on the other side. So we're going to subtract this y over here, and we're going to subtract this 3x over here. Is everybody okay with that step?
Yes.
Okay. And the reason why we do that is because we're solving for one y. When you're solving for one y, we have 2 y's right now. So why don't we take that and find the GCF and factor it to the front. Okay? So that we have y times x minus 1 equals negative 3x plus 1. And then, what's that? Oh, yeah. Bring them that way and bring them that way. Yeah. And then finally, this is y times x minus 1. So let's take that and divide. And so that we get our inverse. You could write it as y. You could write it as f inverse. It's equal to negative 3x plus 1 over x minus 1. That one's the trickiest one you'll have just because it has 2 y's like that. But you'll have to do something like that in your homework, and that'll be on the quiz for sure. Oh, yeah, for sure. Okay?